All right, I also offered to help you with this one because of that stupid microphone. All right, so let's try get this one across. So this is the idea that obviously when there's a wind, the temperature is colder. We live in Minnesota. We know how that works. So if it's cold and there's a wind, then you get a wind chill, okay? But it gets complicated when you're moving. And so then you have what's called a relative wind speed. And in class, we would said that was 11 and 35 here. So let's look at how that works with the Desmos calculator. So in this assignment, my bike has a speed of 15 miles per hour, and the wind has a speed of 26. So if we look at this relative motion that we just set up, I'm going to adjust this here to our case. I'll put the angle of the bike as 0, so he's going straight east on my way to work, and the wind was at an angle of 180, or it was coming from the west. Sorry, the wind would be not going 80. The wind would also be going 0 because it's coming from the west. All right, so there we go. So the wind is going from the west. Let's make the wind start at the same spot as I am. So I'll put the wind here starting at -10, and then okay. So what we can see here now is that the wind is moving faster compared to the guy than it is compared to the bike. And if we draw our velocity vector diagram, we can see here that we have the velocity of the wind. And in our case here, the wind speed was at 26 miles per hour. And then I have the velocity of the bike going at 15. And I'll try to draw these to scale. All right, so if after 1 second goes by, a particle of wind goes from here to here. After 1 second goes, my bike goes from here to here. But if we look relatively, after 1 second, I'm here, and that wind that we started together is up here. So that means that the wind is blowing by me this much, which, as we can see just from math, is the difference between 26 and 15. We can also use our equation that the relative wind speed is going to be equal to the speed of the wind minus the velocity of the bike. All right, so we're going to compare those. So when we subtract things, vector-wise, we're going to have our original wind speed, which is at 26, and then subtracting means adding the negative. So that means I'm going to add the negative. So I'm going to go from here, and instead of going forward, that 15, I'm going to do the opposite because I'm subtracting. I'm going to go back that 15. And so now if we start here and we end here, we can see that that's a difference of 11. Now this works pretty easy when we can do to the right is positive. So we get a positive 26 minus a 15, and that gives us an 11. And that's what we put in here for our relative wind speed. Now, when we have a relative wind speed of 11, the actual wind chill is much less than the stated wind chill, because the stated wind chill is based on the idea that the wind's coming at you at 26 miles an hour. But if I'm running with the wind, then that means the wind's only hitting me at 11 miles per hour, which gives me a lower wind chill, which what we said here was pretty cold. So biking to school for 40 minutes is in -28 wind chill. It does get you pretty cold. But coming home, the wind was still from the west, but now I'm going west. I'm going into the wind. So the wind's at 20, and now I'm coming at 15. So if we look at that here, now we have the wind speed here. I'm going in the opposite direction. So the biker's speed now is going west, so 180 degrees. Not 1800, 180. So now I'm going opposite here. And I'll put my starting point here so we can see it. Oops. I'll put my starting point here at 20. All right, so now we can see that I'm heading into the wind. And so that means if we have this wind speed here, if the wind is coming at me, now it's coming at me at 20, but I'm going into the wind at 15, we can see the relative speed. So if I start here, and this wind comes all the way over to here and gets to me, because we meet in the middle, that means that it seems like that wind was coming at me at 35 meters per second. And again here, if we do the math, the relative velocity, the relative wind velocity is going to be equal to the velocity of the wind minus the velocity of the bike. And here I got 20 minus, but in this case here, it would be a -15 because it's going to the left. and we get a relative speed of 35, or the wind's coming at me much faster. And if we look here, the wind is hitting me faster than it is hitting the guy because I'm flying into it. All right, so when we look at that, now the relative wind speed at 35, even though it wasn't as cold, gives me a relative wind chill of -34, which what I said was really cold. Froze my eyes shut on the way home. I remember that day, even though it was like, what, 5 years ago now? It was cold. All right, so now we're gonna do the same thing, but we're at angles. And this is where it gets a little bit yuckier. We have to be careful. So let's set this up in Desmos. I'm going east, and the wind's from the northwest. So let's go back to Desmos here. I'm going to the east on my bike, so that would be a bike direction of 0 degrees. And the wind's coming from the northwest. So that would actually mean that the wind is flying downwards. So that would be, we could pay -45, or we could go all the way around the circle, 90, 180, 270, 315. So let's put 315 for the angle of the wind, and we'll see if that's working for us. Okay, so now that's coming from the northwest and going downward. And I want to see what it looks like when it's hitting me. So maybe I'll start the wind. I'll start it up here at, let's start it up here at 20. Oops. All right, so now it's starting up high. And I gotta start the bike here. Let's go back to the bike. We'll start the bike at -10. Okay, so now we can see how that wind is hitting across me. All right, this gets a little bit hard to figure out the relative speed, because now we have a wind speed in this direction, and I have a biking speed in this direction. So if we look at components, we can see that this wind has a horizontal component and a vertical component, and my horizontal biking is running away from the horizontal part of the wind. So we could think, if we put it up here, I'm going here. So the relative wind speed, it's going to be this missing part, much smaller. But I'm still going to have the horizontal part. So if we look here, that the relative wind speed, the wind's hitting me from my back, this missing part, but it also still has this downward part here. So if we put those together here, if I go down and over, the relative wind speed is somewhere in this direction. Okay, so it's not hitting me from the back as much because I'm running away from it, but it's hitting me from the side just as much. We can see that same thing if we do our vector map. So if we have this angle, remember, the relative speed is equal to the velocity of the wind minus the velocity of the bike. So here it is, the velocity of the wind was at our, I should do it in red, was at our 45 degrees. Oops. All right. And then, hold on. I drew that in the wrong spot. Let's clean that up. Okay, so we got the velocity of the wind. Here's our -45. And then I'm going to subtract the velocity of the bike. Well, the bike is moving forward, but I'm going to subtract that. So I'm going to add the opposite. And you can see how that gets us this piece right. It ends us up. It's the same thing as ending up from here to here, which gives us our relative wind speed. So that's kind of a quick graphic of how this thing works out. That would be the relative wind speed. How do we do this with math? This gets a little bit messier. We have to break it into components and figure out the parts. So in the horizontal, we can see the V relative. The horizontal, it's going to be the velocity of the wind. Oops. It's going to be the velocity of the wind. This always slows me down when I got to erase. It's going to be the velocity of the wind in the x direction. So we can do the relative x. It's going to be the velocity of the wind in the x direction minus the velocity of the bike in the x direction. So for us, that's going to be, we got to do the speed of the wind, cosine the angle of the wind, minus the, what we're going to do, minus the negative, because we're going to reverse the direction. So the easiest way to do that is to reverse the direction of the speed. then we don't have to mess with the angle. We could do the same angle but in the opposite direction. So this is going to be plus the speed of the bike cosine angle of the bike. Let me try and move this over here a little bit to get that in there. All right, in the same way, it's going to be like that for the y. So if we go into our relative velocity calculator here, and I do this in the x direction, so the velocity of the relative velocity in the x direction is going to be the speed of the wind cosine the angle of the wind. Now I'm going to do plus here because it's not, we got to do minus. We're going to do minus the velocity of the minus the velocity of the biker. So let's see. So the velocity of the biker is going to be the speed of the biker cosine angle of the biker. All right. So we can put those in there, and in this case here, the speed of the wind Tuesday morning is 9. The angle of the wind is coming, we said that was 315 because it's coming from the northwest. And then we're going to subtract speed of the bike, which is 15 miles per hour, cosine, and my angle here was 0 because I'm going to the east. So when we do that math, we could do another Desmos. I'll do a second Desmos window here so we can keep our calculations separate from our animation. If we look at that here, I have 26 cosine 315. Oops. I froze my computer. Apparently my mouse broke. So let's see, we got 26 times cosine of 315 minus 15 times the cosine of 0. Now again, remember, for this to work, we're doing our angles in degrees, so make sure you turn Desmos 2 degrees. And when we do that, we're getting a relative velocity of 3.38 at my back. Now remember here, that was the idea that the wind here is not moving horizontally, is not going to hit me as fast because I'm running away from it. So it won't get to me as much. So that part's 3. But we still have to do the vertical part. So the velocity of the wind relative to us is going to be equal to the speed of the wind sine theta in the y. So sine 315 minus 15 sine of 0. Now sine of 0 is just going to be 0 because I'm not moving up or down on the bike. I'm just going to the east. But if we put in this other part here, so we got 26 times our sine of 315. That gives us negative 18.38. Negative because it's going down. And that makes sense for us here too. Because just if we say to the right is positive, we're also saying up is positive in the vertical. So we get negative 18.38. And this other one here was 3.38. Okay, so so now we have the horizontal and the vertical components of our relative wind velocity. Of course, now how do we put that together and find the actual velocity? Well, it's just like Pythagorean theorem. So if we're going over 3.38 and our wind speed's going down 18.38, what is our hypotenuse going to be? And for that, we got to use the Pythagorean theorem. We get a squared plus b squared equals c squared. And so if we put that into Desmos here, we're going to have the square root of a squared, 3.3848. I'll put some more decimals in there, plus this, the negative goes away, 18.33848. If I put those in, squared. Oops, I'm not showing you guys that. Okay, so that gives me a relative wind speed of 18.69. So this would look good. However, when we go back here, the speed of the wind is 9. So I don't know where I got this 26. So let's go back to Desmos in here, and let's fix this. These are supposed to be 9. Speed of the wind's 9. So let's see if that makes sense to us. Let's draw that on the picture. Except now, the way this works out here is if this is 26, I drew this a little bit long here. Actually, my bike speed here is actually greater than the component of the wind's horizontal speed. So that means that the relative wind makes it feel like it's coming at me. And that's shown here when I got this negative number here. That means the relative wind means it's coming at me, because the horizontal component of the wind is less than my bike speed, which gives me that negative number. So we should put these in here. Negative 8 point, well, I don't need the negative. I'd rather not use it just to make sure nothing's going wrong. 8.636. 20 point, let's see, 6.36. Like so, 6.364 if we round up to 3 digits. And that gives me 10.727. And that makes a little more sense here. So let's get rid of this. In here, we got the relative speed is negative 10.727. All right, and I got a temperature of -2. So let's do the wind chills on that one. So I'll go to my wind chill calculator here. Wind chill calculator. All right, so now I can put this in here. The temperature we had was -2. My wind speed was 9, and I can convert that. So that gives me a -17.5. So with a wind speed of 9 here, oops. With a wind speed of 9, it's a 9, and a temperature of -2, that gives me a wind chill of -17.5. So -17.5. And my relative wind chill, I don't use the 9, I'm going to use the -10.72. So the wind chill now is 10.72. The negative just telling you the direction, and that gives a temperature of -19 for the regular wind chill. So as you can see, not too bad. It's much less than the -28 or -34, -19. So there's another example. Tuesday afternoon's a little bit easier because the wind's coming from the north. That makes our components a lot nicer. So if we go back to our decimals here, we can clear this all out. Now the wind's at 90 degrees, so I'll come down here, I'll make the wind angle of the wind is at, it's coming from the north, so that means it'd be 270. So now it's coming from, the wind's coming straight south here. It's looking good. I'll start the wind at 0, just so we can see it hitting. So now it's pretty easy to see that the bike is going this way. The wind is coming down. So what does it feel like the wind's hitting you? Well, if the wind's coming at you sideways and from behind, it feels like the wind is coming from that direction. So we don't even need to figure out the direction here because it's already in components. We can just go straight to a squared plus b squared equals c squared. So this is going to be our a, our b, and our c. And using those components, since they're perpendicular, we don't have to do the sines and cosines to find each part. We just have a horizontal part from the bike and a vertical part from the wind. So if we look at our values here, we have a wind speed of 9. So if we go to our calculator, we're just going to have the square root of 15 squared, which is my biking speed, plus 9 squared. which is the wind speed. So that gives me a 17.5 to 5 wind. So we put that 17.5. You don't need this negative here because it's wind speed, not velocity, so we don't have to include direction. It's kind of silly there. So 17.5, and now I have a temperature of 4. So let's do that first. We got 9 and 17.5. So back to our wind speed, 9, 17.5. That gives us a negative 9 degree wind chill. All right, so we'll put that in here. That gives us negative 9. And now if we do the relative, we have to up that wind speed to 17.5 because of the relative wind. Well, that was that one. 17.5 was our relative, so that's going to be negative 9. And let's put in 9 for our wind speed. Am I putting these numbers in right? I feel like I'm... Temperature's 4. Oh, goodness. Let's erase this. Okay, so we got a temperature of 4 and a wind speed of 9. Let's do that. We got a temperature of 4, wind speed of 9. That gives me a negative 10.2. All right. And then if we do that again, temperature 4, but now we have a wind speed of 17.5. And we convert that. That gives me a negative 15.6. So we can put that in here. Negative 15.6. And again, not too bad at all. So it's looking good. All right, so that leaves you guys to do this Wednesday morning prediction. Now this is a southeast wind. So that means the wind's coming from the southeast. So if we think about what angle that would be, it would be 90 plus 45, so it'd be 135 degrees if we're measuring from the positive x-axis for a southeast wind, because that's the direction it's going. It's coming from the southeast. So this is why it got so cold here, is because when I was biking to school, part of that wind was right in my face, and then part of that wind was to the side. All right, that was the prediction. Okay, but then in actuality, this is when I got up in the morning, it was a little bit windier and it was a little bit colder. And those things together gave me the famous coldest yet. It hurt really, really badly. So hopefully you guys can do that. Remembering here too that there is extra credit. If you want to set this up, you can make a spreadsheet to do all this, and it can be a lot easier because you're doing some repeated calculations. The one thing on the spreadsheet, make sure you're measuring the angles from the positive x-axis, and then the direction of your components up, down, left, right will be taken care of by the sine and cosine. So get those in. Come to office hours if you need help.